Welcome to EduPorm EdTech. You're watching expert chemistry lectures with Abhinav Gaur. In this lecture, we will discuss the thermodynamics of adsorption. In previous lecture, we discussed that thermodynamic is an exothermic process. So, for the process to be exothermic, there are some key points which are shown on the screen. You can also see these points through our notes which are available on our mobile application. Now let's start. The important factor featuring adsorption is the heat of adsorption. During adsorption, there is always decrease in the residual forces of the surface. That is, there is decrease in the surface energy, and that decrease appears as the heat. In the mechanism of adsorption, we discussed that the molecules which are present on the surface, they experience the net downward force, and these net downward force decreases when adsorption occurs on the surface. So due to the decrease in these net downward force, energy is released. That means heat is released. So during absorption, there is always decrease in the residual forces of surface, and this decrease in surface energy appears as the heat. Now, adsorption therefore is a exothermic process. In other words, the delta H, that means the change in enthalpy of adsorption, is always negative. When gas is absorbed on the surface, the movement of gas also decreases. Imagine this is a surface, and these are the molecules of gases around the surface. So these molecules can easily move, they can easily vibrate, as well as they can easily collide with the surface and easily collide with each other. So in the gaseous form, they are highly moving and highly unstable. But once they are deposited on the surface, their movement get restricted. So we can say that the entropy change, that means the delta S, because entropy simply represents the randomness, so the entropy change of reaction is also zero. Now, for process to be spontaneous, spontaneous means the process which occur as it is without any external agent like heat, pressure or catalyst required. So, for the process to be spontaneous, the thermodynamic requirement is that the delta G must also be negative. So, we studied that enthalpy change is negative, entropy change is also negative, and the change in Gibbs free energy should also be negative. We know that delta G is equal to delta H minus T delta S, and delta G can be negative if delta H, that means change in enthalpy, have sufficiently high negative value as minus T delta S is positive. Okay, T, we have this minus sign here, and S, we have studied that this S is minus. So minus minus will give the positive value to minus T delta S. So to make delta G negative, the value of delta H must be highly negative. It must be highly negative. Okay. Thus, in an adsorption process which is spontaneous, combination of delta H and combination of delta S makes the delta G negative, and as the adsorption proceed, this is very important point, as the adsorption proceed, delta H becomes less negative, and ultimately delta H becomes equal to T delta S, and at that case delta G is equal to 0, and when Gibbs free energy is 0, state of equilibrium arises. So what you guys need to learn is that for adsorption, delta H, that means change in enthalpy, is negative, and change in entropy is also negative, and for the process to be spontaneous, change in Gibbs energy is also negative. Delta H should be highly negative because minus T delta S is positive, and when delta H will be negative, then only the process will be spontaneous. Now let's study two different types of adsorption process. So adsorption is of two types. First we have physical adsorption, and second we have chemical adsorption. In case of physical adsorption, the forces which are operating between the adsorbate and the adsorbent are physical in nature and they are usually weak van der Waals forces. The heat of adsorption is also low, which is between 20 to 40 kilojoule per mole. This process is reversible, that means desorption occur easily, and this process is usually inversely proportional to temperature. So for physical adsorption, the graph look like this. When we increase the temperature, the extent of adsorption decreases. It does not require any activation energy. Activation energy, we know that it is the minimum energy for the formation of product. So in this case, because only van der Waals forces are present and no bond formation is taking place between the adsorbate and the adsorbent, so no activation energy, that means no bond formation energy, we can say, is required. It takes place at low temperature and decreases with increase in temperature. It is not specific in nature. Any gas, we can say, it is not specific that a certain gas will get adsorbed on the certain metal. It is non-specific in nature. It increases with increase in surface area of adsorbent and it forms multi-molecular layers. That means this is the adsorbent, this is the first layer of adsorbate, this is the second layer of adsorbate, and this is the third layer of adsorbate. So it forms multiple layers. Now chemical adsorption. In case of chemical adsorption, the force acting between adsorbate and adsorbent are chemical forces like ionic forces or covalent forces. The heat of adsorption is also high, between 40 to 400 kilojoule per mole. This process is irreversible, that means desorption cannot be done easily. Efforts to free adsorbed gases give different compounds. If we try to remove the adsorbate, we may get different compound instead of the pure adsorbate. It requires activation energy because there is formation of bond, so sufficient energy will be required for their formation. This type of adsorption first increases with temperature, then it decreases. So when surface is available, the process is directly proportional to temperature, but when surface is consumed, let's say at point C the surface is consumed. So when surface is consumed, then the process of adsorption is inversely proportional to temperature. So extent of adsorption versus temperature graph is bell-shaped graph. It is highly specific in nature. Only a certain gas can adsorb at a given surface. It also increases with increase in surface area and it forms unimolecular layer. So this is our adsorbent and this is the layer of adsorbate, and only unimolecular, that means only one layer will be formed instead of multiple layers as in physical adsorption. So this is all about types of adsorption, Freundlich adsorption, isotherm, and as the name suggests, we are talking about isotherm, and we know that isotherm means that temperature will be constant during the process. So according to Freundlich adsorption isotherm, the extent of adsorption is directly proportional to the pressure when temperature is constant. Here in this graph, this X represent the number of molecules of adsorbate, number of molecules of adsorbate. And what is adsorbate? We have discussed that adsorbate is a substance which get deposited, and this M represent the mass of adsorbent, that means the mass of surface on which adsorption is taking place. And this X upon M is called as extent of adsorption, and this is directly proportional to pressure at constant temperature. And it is not just proportional to temperature, Freundlich suggested that it is proportional to 1 by n power of pressure, where n is greater than 1. Now, when we remove this proportionality sign, we get an equation which is extent of adsorption is equal to k p to the power 1 by n, and this equation is the Freundlich adsorption equation.